Hello, this is John from caveofprogramming.com, and in this tutorial I'm not going to do any coding just because the coding that I've done since the last tutorial, which I'm going to explain to you now, is very minimal, and most of what I've done is kind of graphically orientated and it's not necessarily going to be useful to you. And I did have it in mind to show you an algorithm in this tutorial that finds the bounding box of the visible area of the bitmap. But what I realized is, after thinking about it, that's such an inefficient thing to do. And if you've got an area in your bitmap that's the bounding box and some of it's transparent, it's much better just to hard code the bounding rectangle values than it is to keep finding it all the time over and over again whenever you run your game. So what I've done is I went to Gimp and I just ran this image autocrop image feature, and that removes any transparent areas of the image except for the bits that are needed to make it kind of rectangular or square. So I've got rid of most of the transparent parts of my image and my shadow, and that left me with a little problem, which is that now if I put the image on directly on top of the shadow won't be in the right place. In fact, I could actually have removed a lot more from this shadow, because the only bit that you actually see is this bit on the left here, and the middle bit is obscured by the actual image. So if I wanted to be more efficient, really I should remove even more of the shadow. But I've cropped them down both quite a lot, and what I did was, in the init method of my sprite class, this is where I'm supplying the bitmaps, the shadow and the image. I'm also now supplying a shadow offset X and a shadow offset Y. And I just store those in private instance variables in sprite.java, and then when I draw the shadow, I add the shadow offset X and to the X coordinate of the shadow, and I add the shadow offset Y to the Y coordinate of the shadow, and then when I call sprite.init, I supply offsets that move the shadow to the right place. So it's very simple, and the end result is this. But the great thing about it now is that I actually commented out this update just temporarily. But now if we allow the ball to bounce again by running update ball.update, then the great thing is that the bounding box of the image really is the bounding box of my sprite now, and that means that with a bit of luck, luck shouldn't really be necessary, but hopefully the ball will now hit the edges of the screen. And the alternative to that, which I was going to do, was define the bounding area programmatically, and then when I check in my ball to see where it's hit the edges of the screen, I was going to check it against a bounding box that I'd defined programmatically somehow, but that was ridiculous really. This way is much better. So now it actually doesn't look perfect. Oh, it does look perfect. You know what? The ball is actually hitting the exact edges of the screen, but because the screencast is slow and it only updates every few frames, you don't see the actual edge of the bounce. But so you're going to unfortunately have to take my word for it that now we've got the bounding box right, and I've trimmed down the image to get rid of all the extra transparent stuff. It is actually perfectly hitting the edge of the screen. So that's it for this tutorial, and until next time, happy coding.